So we are recording since nobody's here. As always, I guess that means I get to just talk about whatever I feel like talking about this week that is somehow relevant or pertinent to the lecture or lab course as I so choose. I think set up so that there's supposed to be at least 3 of these video discussions per course. And because of the way that we've decided to make lecture and lab separate courses, I think I have to do at least 3 in each. And so while I would otherwise be inclined to just talk lecture stuff because there's a lot more material since it's 3 hours worth, um, probably better do something related to lab just to meet that arbitrary quota. Um, and this week's lab is the building a spring scale lab. So what do you need for this week's lab? You need a spring of some sort. You can do multiple springs or just one spring. But I think multiple springs will be more helpful for when you do the later lab on spring oscillations. Remember that I have recommended, whoops, need to share my screen here. Um, yeah, as I was saying, remember that I have made some recommendations before about where to get your springs, like where can you find them on Amazon and stuff. These were, whoops, called the ISCO springs, or the company, I guess, that makes them is ISCO, EISCO. These are, I suppose, the supplier for companies like Pasco and maybe also Vernier, who are and Fisher Scientific, Arbor Scientific, all those guys. Fisher, not Scientor, Scientific, um, and then Arbor, etc. These are sort of like the vendors that universities use, including, of course, Troy. So like Troy usually goes through Pasco and Vernier and Fisher. But in any case, you can buy these off of Amazon. I don't remember what the list price is on Amazon. Let's go ahead and check to see if it's changed since last time that I looked, which was earlier this year. Love how Amazon just doesn't know who I am because I'm not signed in, and thinks that I want either a Kindle or a bikini, or a Father's Day gift from a son. Great going, Amazon. I'm sure one of those things is probably going to fit. But no, what I'm here for is the ISCO spring. There we go. And boy, they've got a lot of options, but the one that I used is not any of these that's showing up as their early ones. God, they've got quite a few options here. Let's see if we can find a set of 3. This right here would be sufficient, but you can get these for cheaper. In fact, having 2 identical springs is perfectly adequate for doing any of the labs you want. I guess they've discontinued the one that I originally recommended, which makes sense. I check like once a year, so call this the check. Let's go back here and pull open our handout and see if the link is still active. There it is, but it's currently unavailable. So, you can't get these anymore. But this right here is what is available, and it is fine. These are the same company. Probably these will be identical springs. There's instructions for how to deal with that. So, hopefully you've got your springs. by the point of watching this video, but if not, here is where you can go to get them. And let's go ahead and copy this over into an announcement into our course. So now that you have your springs, what do you do with? Well, basically what you're supposed to be doing is just taking some masses. And what I used when I've done this lab the last few times is just a couple washers that I picked up from the hardware store. Specifically, I went to Lowe's, but Home Depot, Ace, any of those guys, any of the local ones even should have some sort of washers that you can use conveniently to do this lab. And so what you're going to want to do is hook them on to the spring. And then when you let them go, you see that the spring stretches a little bit. If I take them off, it's like this. If I put them on, it's like this. It's not very much of a stretch, but it is enough to measure it if you've hung it from something. Using my webcam, I don't necessarily have a good system to hang this from and get pictures of the spring and get pictures of everything else that you might want. So, I'm just kind of trusting that you guys are smart enough to read between the lines on that one. Hang it from something a little more stable than your hand. Okay. And then if I now have 5 of them on instead of 2. And if I do that, like here's how long the spring is now, here's how long it is with only 2, here's how long it is with 5, and so on. And then you should be using some sort of a rigid meter stick like this to measure the length of your spring from end to end. So that's basically what you're doing in this week's lab. Then what you ultimately want to produce with this is a graph, and the graph should be on graph paper or the computer. I'm just hand sketching it, so it's not going to be as nice looking as yours, but you would have something like how much it stretched by. So delta X, the stretch. You could put this in centimeters, but really you want this in meters, especially for that future lab. And then over here you have F, this is the force, and this should be in newtons. And remembering that F for the spring is equal to the weight of the masses that you've attached, so of the washers. So that is the mass of the washers times G, or you could figure out what the mass of one washer is, and if they're all identical, then multiply by how many you've hung from it, if you'd like. So you should end up getting a graph that basically just does something like this, and then you need to have a line of best fit through your data points. And you should use a ruler to get a nice straight line. I don't have a good setup again to draw that here. Slope of this line is called spring force constant. We represent it with a K or a K sub S. And you're going to need this K sub S in a future lab, specifically the one that says formal lab report on it. Okay, so that's it. That's basically what you're doing. Maybe a brief reminder in case you've forgotten or haven't used this enough times. M, this is mass, and this should be in kilograms if you want your force to be in newtons. G is 9.8. Basically, it's 9.8 newtons per kilogram of mass. So that's maybe also worth having. So as a brief example, and I'm just going to try to cram it all onto this page. Let's say that you have mass is, let's say 25 grams. Then your force for gravity and therefore your force for the spring will be 0.025 0.25 kilograms, because this is times 1 kilogram per 1,000 grams, or in other words, 0.025 kilograms. So 0.25 kilograms times 9.8, and this is newtons per kilogram. So when you multiply those numbers together, 0.25 would give me 2.245. So I guess we have 0.24, basically 0.24 5 newtons. And as a double check, maybe plug into the calculator. 9.8 times 0.025 is 0.245. Okay, so that's the major calculation that you're doing in this week. That's all that I really want to talk about today. I'm going to cut myself short because we're kind of hosting a visitor at our department today, a person that we're trying to hire for physics. And so I want to be kind of a good host and, actually interview her and that kind of stuff. So that's the end of today's little video discussion session. And if anybody is watching, then thanks for watching. And good luck with this week's lab, I guess. And of course, if anybody ever has questions for lecture or lab, you can send them to me. And if you ever want to just come at this time and discuss them virtually, if you send them in advance, then we can just discuss that virtually. Or you can just pop in and we can discuss it virtually. That's fine with me too. Otherwise, I'm just going to keep doing this. So thanks anybody who's watching after the fact, and guess I'll see you or not next week.